Welcome to SDN Tech Forum. This is AWS CrashCourse, and our focus is infrastructure as a service. So far, you have seen compute, storage, and we have talked about auto scaling group, load balancers. Now we are touching on final piece of infrastructure as a service, which is monitoring and alerting uh, using AWS CloudWatch. All right, so let's see what we have in agenda today. Before we uh, go to the CloudWatch, let's revisit, take a step back because it's been a while. We looked into cloud computing definition. So let's review the NIST definition one more time. So cloud, according to NIST, cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. And these resources can be network, server, storage, application, or services. Again, these configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. That means emphasis is on self-service. The cloud model is composed of 5 essential characteristics, and we have listed the characteristics. 3 service model: infrastructure as a service, platform as a service, software as a service, and 4 deployment model: private cloud, public cloud, hybrid cloud. So, what are the 5 essential characteristics? On demand, that means a user can do pretty much all the things as a self service. Broad network access, ubiquitous access, internet based access. Resource pooling, it is a shared pool of resources. Rapid elasticity, that is the topic what we are going to build next. Auto scaling groups, rapidly or dynamically scale up and scale down based on the requirement. And measured service, obviously you have to keep the cost in mind. So what we have in agenda: introduction to AWS CloudWatch, getting started with AWS CloudWatch, collecting CloudWatch matrices, how to set alarms and notification for CloudWatch, how you can use CloudWatch to analyze the logs, and this is really powerful. Think of Splunk-like solution, and then summary or conclusion. So, introduction to AWS CloudWatch. AWS CloudWatch is a monitoring and observability service that provides real-time insight into performance and health of your AWS resources and application. It helps you keep an eye on resource utilization, application logs, and other matrices to ensure optimal performance and availability. So, as you can see, it helps you monitor and provide observability. It using CloudWatch, you cannot just keep an eye on resource, but you can also take actions. And CloudWatch is natively integrated with 70 plus AWS services, and list is keep on growing, including EC2, DynamoDB, S3, ECS, Lambda, CloudTrail, and so many others. Right? You can also monitor or generate custom matrices for your application. You can use this data to monitor trends, set alarms, troubleshoot issues, and optimize your infrastructure. So you can think of this like a very powerful cloud-based network management solution. Getting started with CloudWatch, since it integrates with a lot of AWS services by default, like for example, EC2 users are automatically registered with Amazon CloudWatch, and EC2 basic monitoring is available at no additional cost. You can upgrade for a detailed monitoring, that means per minute per minute based monitoring by upgrading your package. But by default, all the EC2 instances you are spinning up, it is monitored every 5 minute interval. Also, CloudWatch automatically monitor uh, load balancers and EBS volumes. And for load balancers, request count and latencies, EBS, read write latencies, these things are monitored by default. Collecting CloudWatch matrices. So how CloudWatch collect matrices, right? Whenever we want to collect some performance data, think of agent, right? So agent need to be available at the source. CloudWatch logs agent can be installed manually or either through CloudFormation or Chef. So you can use tools like CloudFormation or open source tool like Chef to deploy the agent. CloudWatch agent when installed on your EC2 or on-prem servers. So it's not very specific to EC2. You can install CloudWatch agent on your on-prem servers like a Linux server or a Windows server that enable you to do the following: collect system level matrices from Amazon EC2 instance beyond standard metrics, collect system level matrices from on-prem server. Depend where you are installing that, right? These can include servers in hybrid environment as well as server not managed by AWS. So CloudWatch as a solution you can actually use for infra which is not managed by AWS. Retrieve custom matrices from your application or services using statsd and collectd. So statsd and collectd, two of the data ingestion protocols, and statd is supported on both Linux and Windows. Collectd is supported only on Linux. Setting alarm with CloudWatch. CloudWatch alarm allow you to set threshold on matrices. In previous slide, you saw how to collect performance data, and once you have those performance data or matrices, you can create alarms based on threshold or setting threshold on those matrices and receive notification when those thresholds are breached. This can help you proactively detect and respond to issues before they impact your users. Alarm can be configured to trigger automatic action such as scaling up and down auto scaling group, stopping an EC2 instance, or sending notification to a SNS topic. And this is essentially what we are going to build. We are going to build a ASG group solution which act on a CloudWatch alarm. Every time that alarm goes off, our either we add instance or we delete instance. Analyzing logs with CloudWatch. So far CloudWatch, you saw that it can uh, collect matrices and set alarms, but CloudWatch is also very powerful, just like Splunk, and can help you analyze logs. CloudWatch logs allow you to collect, monitor, and analyze log files from your application and systems. You can use CloudWatch logs to troubleshoot issues, debug error, gain insight into user behavior. Logs can be streamlined in real time to the CloudWatch, where you can search, filter, aggregate them using powerful query language. You can also export logs to AWS services like S3 or Elasticsearch for further analysis. So this is altogether a different capability or a use case for CloudWatch. Finally, summary, especially in our use case, one of the most valuable use case for CloudWatch is its ability to scale resources automatically. By setting up alarm based on specific matrices, you can trigger automatic scaling actions that will increase or decrease resources as needed. For example, if your application experiences a sudden spike in traffic, CloudWatch can automatically spin up additional EC2 instances to handle the load. So here, point to note is CloudWatch doesn't go ahead and initiate or spin up EC2 instances. It is actually based on auto scaling group, but CloudWatch alarms are integral part of that. This not only ensure high availability but also help you to save money by only paying for the resources you need, and that is the beauty of cloud, right? So in next video we are going to whatever we have reviewed so far, elastic load balancers, auto scaling group, and CloudWatch, we are going to put all three theories together and create a working solutions in terms of application which can scale up or down based on the demand. So thank you and stay tuned.